Hello everybody, welcome back to Model Metrics. It was a long gap, but I'm back again with another brand new modeling video. Today's project, it's a steel structure. It's actually single storied parking facility, and entire structure is made from steel frames. You can see the girders, the columns, all these structural elements. We're going to see the modeling of each and every individual structural elements. These columns, these are the UC columns, universal beams, and you see the join of the transverse beams and the Longi beams, and the join between the Longi beams, the connections between them, the connection between the column and the footing. All these things are going to be covered in this single video. Let me go to the visibility graphic. Here you can see the filter. I have filterized each and every individual structural elements here. You see levels, 100 millimeter CC layer, footings, steel columns, ramp. Here, this is the ramp slab, the beams underneath the ramp slab. As you can see, it's pretty transparent, so you can see the transverse beams and the Longi beams. And also I'm gonna show you the connections between these beams, and also you're gonna see the connections between these beams and columns. Here you can see a plate in between that beam and the column, and I placed some bolts over these plates, and also the railings above the slab and the stair too. All these things is going to be covered in that single video. And also I schedulized some of the elements. Right. I'm also going to show you the scheduling of several elements, the material takeoff, the quantification of materials, and the weight of this material. I mean the beams and the columns, all these things will be covered in this single video. So if you have that much enthusiasm to learn about the steel modeling, the modeling of steel structure in Revit, you can see this entire video. I can guarantee that you are not going to get disappointed. So keep watching. Thank you. Let me choose the template. Okay, the browse option. So structural analysis default metric template. This is the template I'm going to use to do this entire steel structural modeling. So here the template, the visible options inside the template, you can see. Alright, so what I'm gonna do now, I'm going to delete these two level 1 analytical structural plan and level 2 analytical structural plan. So let's delete it. Let's click the right mouse, and here's the delete option. Again the right click and the delete option, and also I'm gonna delete that side option. So all these unnecessary things, they all have been deleted. Now it's time to draw the levels. In order to draw the levels, let's go to the east elevation. Here in the east elevation, choose the level and use the CS command, CS, and the peak line option. And now I'm going to choose the offset. Here the offset option, as you can see, the first offset will be 1000 millimeter, which means 1 meter, minus 100 1000 millimeter minus 1 meter. It's going to be the foundation level. Let me name it. The name will be 00 foundation. Level. Okay, it's cool. Now I'm going to name all these levels. Let's keep doing that same task, taking offset the levels, and it will be 2.5 meter, and the peak line option. Here's the offset, the dotted lines you can see. Let me name it again. I'm going to name it as 02. Steel column. Right, I just changed the scale of the text. I made it more small, and the level above that steel column top level, I just deleted that level. Now it's time to take another offset, and that offset, it will be 3300 millimeter, level 5, and it will be 03. First floor, first level parking. Right, first level parking. So here's the 4 levels I just made, and I'm going to make this. Import the CAD files. So here, import option, insert ribbon. I have already chosen the import CAD option. Now let's import the CAD files. So here we go. I am now browsing the folders where actually the CAD files are really located. Here we go. So inside that architect Revit structure folder. Okay, to be design, manage per park. Alright, so as it's the foundation level, so I'm supposed to import the FL ASNCRSTRIFCSN folder. So it will be center to center. Okay, fine. Current view only. So all these options must be ticked. And here the file, the CAD file has been imported. Now CAD file for the ground level parking, each and every level there are corresponding CAD files, so I'm gonna import them all. Yeah, I choose the wrong one. So import CAD. Here's the second one, GLIFC. Let's import that one, center to center position. So open. Here we go. CAD file for the ground level parking. And there's another CAD file which will belong to the first level parking. So 3 CAD file will belong to this 3 level. So everything are being set before, so I just click the open option. So here I have imported all the substantial CAD files for all the project. So CAD files have been imported. Now it's time to place the 100mm concrete layer underneath the foundation. Here the structure ribbon, the floor option, the arrow for structure, floor generic 300mm. I supposed to modify this one, so let's go to the duplicate option and name it as 100mm plain concrete layer. I'm pretty sluggish in typing. My typing skill is horrible. Alright, the name, I have given it a name. Now it's time to choose the structure of the foundation of the concrete layer. The material, let's choose the material. It should be concrete. Sorry for the typing mistake. This one wouldn't be bad. I just made a copy. I'm not selecting the direct option, the direct material. I'm making a copy for that particular purpose. So concrete 100mm, render appearance, there are options in this graphic. You can choose the surface pattern and the appearance of that concrete of different view. Alright, I have selected, modified the material. Now it's time to draw it. Right, let's draw it. Selected the rectangular option. Just drawn the first one. Now what I'm gonna do, there are a lot of F2 footing, so that dimension will be same for all F2 footing. Here it is. So what I'm gonna do, turn on the wireframe mode. So I'm looking over the elevation of that concrete layer, and I want to get it 500mm below that foundation level, so minus 500mm, so it will get 500mm down that foundation level. Now it's time to make copies, so let me turn the wireframe mode on. Here's the wireframe mode. Now I am willing to copy it for all F2 footing. So this is the point. Yes, this copy business will run on till the last F2 column. So the 100 mm concrete layer is getting copied to all corresponding F2 footing. It's making the work more easy. It's just making the copy. Burden has been reduced. After that, after making the copy, we will check the elevation. As you all have seen, we put that 500 mm below the foundation level. Alright, here's another type of column footing, F2 footing. So another concrete layer of 100 mm underneath that F1 footing. Here we go. Right now, let me the elevation. Choose the elevation. Now I'm copying that corresponding concrete layer for F1 footing, so it will be placed underneath the F1 footing. The copy business will go on till the last footing. Okay, it's nice and cool. Let's see. Let's go to the minus 500 mm. Okay, nice. So I have placed all the concrete 100 mm concrete under. I have already pinned all the elements with the drawing, all the concrete layers. I have just drawn. They all are being pinned with the CAD drawing. And now it's time to put the foundation, the footing above this 100 mm concrete layer. Actually, this concrete layer, it helps the footing from getting damaged when the entire footing will have contact with the earth. There might happen some sort of chemical reaction which would reduce the strength of the footing, the concrete, and later on it might damage the steel. Actually, isolate footing I'm willing to place here. So the type option, as you can see, isolate footing, you can regulate the dimensions of such type of footings, the thickness, width and length. So let's name it as F1. Okay, so the dimension that F1 footing is 1600 mm. 1.6 meter will be the width, and the length will be 1400 mm. Let's put the length 1400 mm. Right, now it's time to place it. I need to place it in the center, but it's not in the center now. It's time to align it. AL, the align tool option, the shortcut for the align tool option. Right. Now I'm going copy to that F1. I'm going to copy that F1 footing to all the places where it needed to be truly belong. Copy option is pretty handy and helpful. It saves a lot of time. CO, the shortcut for the copy option. You see there are some misalignment. I mean the elevation is not seem okay. This footing, they're supposed to be placed above the concrete layer, so I am going to make some modification on these elevations, so it will be 500 millimeter above that 100 millimeter concrete layer. What is it? Seems like I made a little mistake. Go to that. Oh God, 500 millimeter. Right, fine. So I had modified the family 500 millimeter. Mistakenly, I gave it 450 millimeter. That's why there was a gap between that concrete layer and the footing. As I fixed it to 500 millimeter, everything seems okay now. Okay. What else? Now it's time to define the F2 footing. Alright, I have defined and placed all the F2 footings, as you can see. Alright, now it's time to place the columns, the UC columns. So we have families for this UC column. UC stands for universal column. So here are the families, but I need to make some modification of the families, the dimensions, you see. Alright, before changing the dimensions, the properties of the flange and wave, I need to know. Here's the flange thickness, which is 18 millimeter. The wave thickness, it's also 18 millimeter as well. All right. So the height is 420 millimeter, and the width will be, yeah. Okay, it seems like 369 millimeter. So these are the dimensions, and also there's a circular portion, as you can see, that little circular portion. I need to know the radius. So here's the option. I am going to draw a curved line here, detailed line. And now I'm going to measure the radius of that detailed line. So DI the radial. Okay, right, so it has a radius of 15 millimeter. That curved portion will have 15 millimeter radius. So the unit UN, the shortcut for the unit option. So if I put it, make it customized, right? 4, 5 is fine. The degree, I am taking a large interval to make the modeling more precise. So yeah, it's 15.2 millimeter, and I take the precision 15.2 millimeter. The radius. Okay, now it's time to make a new family. Actually, I'm not making new family. I am going to make a copy of the existing family and gonna modify it following all these dimensions. So here it is. I'm going to make a duplicate copy of that column, of that universal column. You see, my typing skill is pretty horrible. I'm sorry for it. Actually, the dimension will be 369, but the specified value is 368. But when I'm gonna make the modification or draw that particular UC column, I am going to follow the exact dimension I have just measured in that figure. So 121, the nominal weight, kgf per meter. Then the thing is, I'm going to change all these dimensions. I'm putting it a little left so that I can see the dimensions easily when I will make the modifications, of course. So here we go. Yeah, the width will be 368.6 millimeter, of course. Then it will get converted into centimeter automatically. This is a very convenient option in Revit. You can put any unit, mention any unit, and it will get converted according to the default option, or the option which has been the unit which has been set right there. Yeah, it's cool. You're done. All right. What else? I think I have defined that particular UC column, UC 420 by 368 by 121. And the thickness of the wave and flange, they're same, right? So I'm going to change the constraint, the bottom constraint and the top constraint. Right, as I am using a view template here, so I am not gonna see that value. There's coming some sort of errors. The base constraint will be foundation level, and the top constraint will be the top level. Right, I have set the value to the fine. Detail level is been fine. Now let's place it and see whether it's matched it's been matched properly. The curved, which was cool too. All these things. Now I'm going to make copy for the same column to the other footings. So the multiple, selected the multiple option of the copy, so the job is going to pretty easy now. I'm just going to make the copy for this particular column. Their places. Here's click F2. Yeah, nice. All the columns of F2 footings will be same. So just making the copy and trying to maintain the proper chronology so that I don't get messed later on. All of them get placed properly in order to make sure that down here, this one. So C is saving all the time, and there are also some API you can use in Python API, which is probably Revit Pi, which would be convenient to automate such sort of work. Or there's another visual programming interface offered by Revit, which is called Dynamo. This one is also handy. Dynamo, it also helps to automate this boring repetitive work. Right, in another tutorial we will discuss about Dynamo. Right, I have placed all the F2 columns. Seems like there's some sort of error I made. The F2 footings in some places. Yeah, here one I forgot to place it. So yeah, the type of mistake that can be fixed in Revit. You don't need to get worried that much. So yeah, I have placed these two missing footings to F2 footings which were being missed. Alright, now it's time to place the F1 column. Before placing that column, I need to get a clear perception about the dimension of that F2 column, the property of flange and wave, their thickness, that circular carved thing. 178. Width is 178. Right now it's time to measure that curve. I'm drawing a detailed line here so that I can measure it. So the DI option, radial, let's see the dimension of that, the radius of that little curve, what it will be. It's 12.75587, making it a little small. All right, as I mentioned earlier, that I want to maintain the proper precision so that it get matched with the drawing. Right now I am making a modification, make a duplication. All right, So there we go, and it will be UC 254 by 178 by 60. Dimensions, it will be 60 kgf per meter, and the width, height, flange thickness, web thickness, and that web fillet option, as you can see, going to represent that radius we have just measured, the connection between the flange and web, maintain some type of curvature. These are hot formed steel. They were not being joined after making these several plates. They were being made the same way in the factory, that I section. I mean, it's not like they got welded or 3 plates. This is called hot formed steel. Here's the fillet radius. I have just put it into millimeter. So yeah, the column, here it is. Now I'm going to rotate it. Yeah, so the rotation has been made. Let's delete these dimensions to make that portion more visible. Let's place that. Those foundation will be moved. Alright, we can fix that error later. Not a big deal. But let's fix the constraint, the base constraint and the top constraint. The base constraint will be foundation level, and the top constraint will be first level perking. So that's how the column will be placed, and I have just locked it so that it doesn't get displaced later for any sort of activities, for the safety purpose. And make sure when you will make such modeling, you lock your elements, or you pin your elements so that they don't get moved from the places they were being placed. Right now it's time to make a replication, make copy, right? So I choose the copy option, or you can choose the shortcut command CO and click that multiple option and just keep making copies. Yeah, it's nice, perfectly matched. But what's wrong with this one? Seems like I didn't make any mistake. I can tell you certainly I didn't make any mistake, but there are some error in the CAD drawing. You see, this one matched properly, but that one, perhaps the CAD drawing, I mean the dimension of that UC column was not maintained properly, so we saw a small gap between the CAD drawing and the actual column, the actual Revit model we just placed. Anyway, we can ignore such small error. It's not that big concern. Or if you think that you can consult with the architect or with the structural designer. Actually, we are the modeler, we make models, but we should have some incredible knowledge about structural modeling, structural load analysis, how the model are made, and also some code and restrictions and rules of modeling, some building codes as well. So yeah, here it is. We have placed all the desired columns. Now it's time to pin them. It's time to pin them all. I'm going to pin all these columns. Here it is. Alright, with the drawing, all these things I have just selected. I'm gonna pin them all. There's the pin option so that it never gets displaced. Alright, now it's time to place the ramp. It will be from the ground level parking to the first level parking. So the ramp option I have already selected. Now it's time to define the boundaries. The boundaries with the ramp, the big line option. Let's lock it after putting the line. There will be another line, and I'm gonna lock it too. Now the riser from here to here. So which portion is downward and which portion is upward? Right, I'm trimming them so the boundaries get closed properly. Right here we have a little warning, but it's not that much concerning one. Now let's select the constraint, the base constraint and the top constraint. The base constraint will be ground level parking, and the top constraint will be first level parking, but the slope, whether it's been maintained properly or not, it's a big matter of concern. I'm taking a section to check the slope, section, reducing it a little bit. Yeah, let's see. The right click, go to view. You see, it's not been properly aligned. I selected the base constraint, ground level parking, and the top constraint was first level parking, but it's not been aligned with the level properly. So I think I need to modify the family of the ramp. So let's select it. Where's the ramp? Okay. The length, we measured the length and the height. Here's the length and the height from the ground level parking to the first level floor. It's 3300 millimeter, right? So yeah, so this thing will help to define the slope, and through here's the calculator option. So the width, the dimension I took here is 22050. 22050. Stake 5. Yeah. And this fraction, right, I'm considering them all. As I told before, I want to maintain the proper precision, so divided 300. So here's the value is 6.6818112. So Yeah, let's select the ramp. I just selected the ramp, edit type. Here I'm gonna put the value 6.681. All right, this will be enough. No need to consider much decimals. Okay, fine. Now, yeah, wow, it's great. You can see the alignment got aligned properly. So the ramp, I have just put the ramp from the ground level parking to the first level parking. It's been aligned properly, but there's a problem about the direction. All right, I'm making visible in my 3D view. The railings were not visible in the 3D view. I just turned the visibility on and put that shaded mode on as well. So I'm removing the railings, and also I need to change the direction of the slope. That portion will be downward, and yeah, so here just make it click. Yeah, so from that portion the vehicle will move upward. As you all know, it's a parking facility. Here we go, the ramp. Now it's time to place beams underneath this ramp I have just drawn. So yeah, I just turned the wireframe mode so that I can see the beams underneath the ramps. I made some modification to the visibility graphic in order to see all these beams. So yeah, they are all getting visible. All right, so here we go, the beam option, universal beam, and you can see the beams dimensions are being given. UC beam, there will be universal beam as well. So yeah, they are predefined. Seems like one UB 305 by 165 by 40. So they have been given. I'm just drawing a beam randomly to find detailed so that the entire beam get visible. All the detailed thing get visible. So yes, there it is. Now let's take a section and see section 1. Right, so where's my beam? Here it is. I am unjoining this point. Joining disallowed. So when you turn off that option, the joining will be disallowed. It will not get joined with other beam if you draw something. Right now, for the convenience, I'm hiding these columns. Right. The constant reference level it's taking a little time to hide them all. Alright, I just made an angle. You can see the cross-section rotation is 8.5117 degree. I just adjusted that rotation, and you see the jet justification, I put it 3300 millimeter below the existing level, which was first level parking. Then I made the rotation. Alright, so I'm making some change in the view range so that I can see that beam. The bottom level will be foundation level. It will also foundation level. Yeah, now the beam is it got visible. Let's just just yeah, let's see whether it gonna work or not. I'm going to align this the gap between the ramp and the bottom surface of the ramp and the top surface of the beam, and it is 5.46, and I'm going to add it with the jet offset value. That means I'm going to put that beam a little bit up, 5.46595 millimeter up. So yeah, the adjustment, let's see now. Perfect, it worked perfectly. Nice. So now let's make the copy. Actually, I'm drawing a detail line, and I'm going to take an offset so that I can place these beams precisely. These lines will help me to get proper snap when I will make copy of the same beam, of the similar beam, right? So here the decline option, the copy 2 meter. So this beam will be placed in 2 meter interval underneath that ramp, and you know this ramp will help to reach the vehicle in the top level. There it is. It's done. So the wireframe mode is on. Alright, I'm just applying a tweak by starting and see does it work or not. Yeah, it's working. So the thing is, the end point and the start point, if you make some little changes there or make it a bit of inclined, then it will work probably. And not probably, certainly it must work. So it's working now. So the starting point of the beam and the end point of the beam, the position, if you make some changes, put some values right there and make them 0 again, and then start that copy, you start using that copy tool, it will work. It will work then. Now it's working fine. Great. So yeah. So here's the thing. I just the constraint will be removed then, right? So I'm selecting all these lines, and yeah, I just deleted all these lines which I used to take offset. So yeah, here it is. I have placed all the beams underneath the ramp. Right, now it's time to place the Longi beams underneath the ramp. Alright, I'm just isolating the ramp and the transverse beams which I placed in the previous video underneath the ramp. Selection has been made. I have isolated them all in the 3D view. Now I have come to the structural plan, first level parking plan. Here you can see the dimensions of the Longi beams, B406178 and 60. This is the dimension, and this beam, it's already been predefined. Alright, and now it's time to disallow the joint. Disallowing the joint so that it doesn't get connected with the Longi beams which I'm gonna place next to this beam. And I disconnected the joint, and you see I am turning the detail into fine. Now I need to incline it. So in order to make the inclination, first level offset and end level offset, you see inside the constraint box, I need to make changes right here. I'm just putting a random value. I want to keep it 200 millimeter. Yeah, 200 millimeter down. The start level offset and the end level offset, if I keep it 400 millimeter down, so I put the negative sign. All right, now I think be able to adjust it. Yeah, the adjustment is done. So I did that thing. So I did that first level offset and second level offset, change the value to break the constraint. Whenever you will break that constraint, then you will easily be allowed to align them. I just used the align tool and aligned it with the ramp. So the Longi beam has been aligned underneath the ramp, the only beam. Now I'm going to make some copy. The rest of the work is going to be pretty easy. I will just make copy and just gonna adjust them. Right, the total length of the ramp, it seems like 21,000 something. I mean, so if I make it 10,000, 8,000. Yeah, it wouldn't be bad. 8,000. Let's move it till the end. It's already been selected. There's the move tool. That point, select, and yeah, I got the snap. Nice. So each Longi beam going to have a length of 8 meters. Now I just simply make copies. I will make a offset of 30 millimeter, a gap between between these beams. And at first when I made that beam, I just made sure that the joint, both of them are being disallowed, so I disallowed them all. Now let's just copy. Here is it, gap 30 millimeter. Okay, I think here I need to make another offset of detail line. So the DL, the shortcut option of detail line 30 millimeter, and the peak line option, here it is. Nice. Now let's make another copy. Get zoomed. Let's get zoomed. Yeah, select it. Oh, let me go to the left. Copy has been made. Now I have to cut it off. That longi beam, it shouldn't get extended that much. Here SL, the shortcut for the cut command. So the cut has been made. I just deleted that portion. So the alignment with the CAD file, with the CAD drawing, it's nice. So yeah, the longi beams of the ramp, the left side, they already been drawn. Let me turn on the wireframe mode. Now what I'm going to do, I'm just going to make selection. I'm going to select all the longi beams and copy them to the right side. So here's the copy tool, or you can use the shortcut CO. Here I am picking a certain point, and in that end point just make a click and it's done. I have copied all the longi beams. Now it's time to connect them. Connect the connection between the transverse beam and the longi beam. Okay, I'm making an alignment, aligning the transverse beam with the longi beam, so that when I will make connection, I can get that advantageous connection, right? Further, I don't need to do any further draw. Oops, that thing got displaced. So I aligned it. Nice. First you select the center of the longi beam, then the outer face of the transverse beam. Or I can use that option where I can select a certain line, then I select multiple beams together. So yeah, multiple selection. Yeah, so the adjustment is done, but it didn't extend that much like the previous ones. So yeah, it's better. I aligned them one by one. AL, cool. AL, this one. Yeah, now it will done. Now I have selected the center. Yeah, all together, just aligned. This tool is pretty handy when you will do multiple alignment. That tool, it will work pretty handy. So yeah, alignment is done. So I'm done with the beam underneath, the beams underneath the ramp. I'm done placing them. Now it's time to place the beams, the first parking level. Right now I'm going to place the Longi Beams and the Transverse beam at the first level parking. First, to just save the project as usual. Here's the UV beam option, and here's the beam 511 by 369 by 70. So I need to modify a beam, a new family of UV beam for that property, for that certain properties of beam. Here I made a duplication, including the value, the length, the width and the height. I'm keeping the same thickness. I have already showed you the detail how you can change the thickness of the wave and the flange, and you know how these things would be done. So in order to avoid complication and save time, I am just ignoring that part. Right, so that I have defined the beam, the Longi beam. It's time to place it, but before that let's take a measure of the dimension. Here's the dimension. Let's see. So it's 13,000 millimeter, which means 13 millimeter. So that Longi beam will be 13 millimeter. Second one, it will be 13 millimeter as well. Let's see the third one. Right, it's also 13 millimeter. Cool. So I'm drawing the beam according to the dimension. So let's extend it. Alright, first I get to allow the disjoint so that it doesn't get connected with the beam next to it. So the disallow connection option. It's been done. Now it's time to put them. Here you go. Now I will just make the replication. Just select the beam and use the command CO, or you can use the icon, the copy icon right there. This point, yeah, press the tab button to get the snapping point. Right, it's been extended a little bit. The extension, let's see. So I'm going to align it. It's cool. The alignment is done. So the Longi beam of the far left side has been drawn according to the plan, and we have some other beams left. The middle portion of the plan. I'm just copying these 3 beams and I'm going to put them the 2 beams, yeah, here. Just press the tab to get the snap. Got the proper snap. It's right here. Sometimes you get very confused which should be the right snapping point, because this line right here it's making me confused. By the way, yeah, this should be this. Cool. This one. Yeah. Oh no. I couldn't snap it properly, so I have to make the copy again. This one and the top one as well. There we go. The copy too. At the top, the modify panel. Whenever you select any particular object, the modify panel will get appeared automatically. Very user-friendly interface Revit offers. Okay, that beam. I'm going to snap it right here. Here it is. Yeah, perfect. Perfectly placed. Now let's place these beams. See, it's making me confused, that line. But that line, it doesn't have any relation with the true beam. Right now, let's align the end point of the beam to a desired length. Yes, it's great. Now let's just make replication. Select this one, make a copy right here. Here we go. Another copy. So I think I'm done with placing the Longi beam in the first level parking. Here it is. You can see the 3D view, all the Longi beam, first level parking. Now let's place the transverse beams. I have already placed the Longi beams, the first level parking floor, you can see. There's the first level parking. I can see the properties of the transverse beam has already been given in the CAD file. UB254 by 102 by 28. So let's see. Yeah, this beam is already predefined. This family is already predefined, so I don't need to make any modification. I guess now it's time to place them. There will be no hassle. It's going to be a pretty easy job, I guess. So let's drag it till that end, and need to make alignment with the CAD drawing. Just select that line and align it with the beam line, and yeah, some extension webbing made here as well. So yes, nice. What I'm going to do now, it'll be pretty easy. Making selection, OP, I got the snap. If you get trouble to get the proper snap point, just press the tab button. It will help you get the snap. So yeah, got the snap. Nice and easy, right? So here it's been snapped as well. Now I'm going to select these 3 consecutive beams and going to copy them vertically in the column wise, right? I did a little mistake. I forgot to turn on that option, disallow joint. Actually, that way, in the case of transverse beam, they don't make that much impact because we are literally dealing with the Longi beam. We're gonna deal with the Longi beam and the transverse beam when we will make joints. So there will be no transverse beam next to that particular transverse beam, right? So this is not that much concerning whether you disallow the joint or allow the joint, but yeah, it's a good practice. You should always disallow the joint. Though I'm not doing it particularly now, but it don't cause me any trouble for sure. So yeah, now let's make copy. And snap. I'm not getting the snap. Which point should I use to make that snap? Let's make the selection again. Selecting all the beams of this particular row. Here it is, this point. Yeah, I got the snap. They all will get replicated just like the previous beams at the top. So the replication process is going on. I selected the copy tool and turned on the multiple option, and also I turned off the constraint option. It must turn off. If you don't do that, then you will have trouble when you make copy of this type of replication. yeah, we got the snap. If you don't get that proper snapping point, don't freak out, press the tap button. But you see this portion is a little bit different, so there will be single beam. I get to replicate the single beams. So here, make the copy, press click option. Let's go down. Yeah, I think I have placed all the transverse beam in the first level parking. Let's go to the 3D view. You see, they're perfectly done. Alright, let's filterize each and every individual element of that modeling. At first I am going to make a project parameter, and it will be a text-based parameter. Alright, let's make the parameter. You can see it will be an instance parameter, and I'm going to name it as elements. Elements and objects. The discipline will be common, data type will be text, group and parameter under text. Alright, and I'm going to select filter list architectural and structural, and right, let's take the structural only. Going to check them all, and filter list I put it architectural and structural both, because there will be railing too. Railing is not a structural element, it's architectural element. Alright, I have made that parameter, and you see whenever I select any particular object or elements and object, that text based parameter get appear in the properties box. So here at first I filter the levels, and I selected all the levels, and inside that elements and object parameter I just named them levels. What if I put all levels? Right, so the all levels. Let's go to the visibility graphic and the filter option. I'm willing to add a new filter, so the add option, edit and new, and that option to make a new filter, and I want to name it filter number 1, all levels. Alright, and let's see where's the level option here in that filter list. Right here, here's the levels option. I just put the tick sign, elements and object is equal to here all levels. Nice. So okay, just click it. Now it's getting up here in the visibility graphic. If I turn off the visibility, then the filters will, the levels will simply just disappear. So following the same way, I am going to make filter for each and every individual element. For floors, that floors, this is actually 100mm concrete layer. These are the 100mm concrete layers underneath each and every particular foundation. So I'm going to make a particular filter for this thing. So here it is. So edit a new option. Let's make it will be filter number 2, 100 mm concrete layer. Let's get below here the floors. It's a floor. It's an object equal to 100 mm concrete layer. Yes. Apply. Okay. Alright. Here I add it in the visibility graphic. Click the OK button. Now for the foundations. All foundations. So following the same method, I'm going to make all these parameters for each and I'm going to make all these filters for each and every individual structural elements. So keep watching. All right, now it's time to connect the beams. At first, let me go to the visibility graphic option, and I'm going to turn off the visibility of turn on the visibility of the transverse transverse beams of the ramp, and turned off the column, turned on that transverse beam of the ramp and the longi beams of the ramp, turned off all the columns. So here in the connection option, I'm going to make selection, drag these two options and press the enter. So the connection has been made, and you can select that priority through choosing clicking that dot. You will be allowed to choose the priority. Alright, exactly following the same way, I'm going to connect the rest, the beams, the transverse beams with the longi beams. Alright, the steel option, connection, there you go, just drag, press enter, here it is. Actually, you can make your own customized connection. There are so many options for the connections, predefined family of connections. You can make your own, and we choose the clip angle option for the connection. Right, exactly following the same way all the connection will be done. All right, here we go. Now I'm going to connect the beam and the column. The beam underneath the ramp, the longitudinal beam underneath the ramp, and the corresponding columns with these beams. So let's make this connection. At first I'm going to isolate these two elements, the beams, that inclined beam and the column. Now I have isolated them. Now let's choose the counter cut option. Using that option, I'm going to cut this long beam. All right, here's option. The line option I'm going to select. Make the cut. So I'm defining the lines and following these corresponding lines, the cut will be made. So at first I selected a plane for cut, and after you select the plane for the cut, you can then draw this shape, rectangular shape. Alright, there will be a 30mm gap between that beam and that column. So yeah, 30mm, 20. We can keep it 20 there. I'm gonna place a plate which will have a thickness of 20mm. So I press the tick button. Now you see the cut has been made. Perfectly splendid. That's what I call. Alright, I'm going to make a plate, so I selected the plate option, and now I'm going to select a plane. Following this plane, the plate will be made. So the rectangular option I selected. Now I selected the plane. Now let's stretch that rectangle. Here we go. See, here it is. The rectangle has been made. So here the plate, you can see it's going to have thickness of 20mm. Yeah, so it matched perfectly, filled the gap perfectly, right? Okay. Now I'm going to place the bolts. So in order to place the bolts, I get to select two elements, press the enter button, then I have to select the plane. This is the plane, press the tab button. Yeah. Oh, I'm getting a little trouble. Alright, here's the plane. I selected the plane. I got a warning sign, it doesn't matter. And now, following that plane, I'm going to draw another rectangle for the orientation of the bolt. I turned on the wireframe mode. Now, stretch that rectangle. So yeah. So this is for the placement of the bolts. Here we go. Sign, so 4 bolts in 4 faces. Okay, now I need to make some adjustment of the bolts, make them more closer, and we can also select the number of bolts, how many bolts there will be. I selected 3. There will be 3 bolts, and the clear spacing between them, you can fix it as well. So here length on side one, so the distance I keep it 80 millimeter. Alright, length on side 2. If I keep it 150 millimeter, then these poles will move farther inside. Yeah, nice. So exactly following this same procedure, I'm about to make connection to all other beams and columns which are right there. The edge distance on side 1, you can change the values of the edge distance on side 1 or 2 to make it more inside or outside from the edge. It's pretty cool, I think. Yeah, so all are getting visible again. So there are some more beams and columns left. I'm about to make the joint to them as well, following the same procedure. All right, let's join the beams, the transverse beam and the Longi beams. There's the filter option. I just disappeared the column from here. Now the connection option from the steel ribbon and the clip angle. Right, now let's make selection. Here we go, press enter and select the priority. Actually, yeah, here through clicking that blue dot you can choose the priority. So this small beam, I mean the transverse beam, is the second priority. It will get joined with the Longi beams. You have to make sure and let Revit know. Alright, it's a little mistake. I'm supposed to choose only these two things, so I get to delete this connection. It's totally unnecessary. You can click that connection and use the command CS. It will directly take you to that option. We're getting a little warning, but you don't impose that much impact. So yeah, again CS, again CS command, select the two objects, the two beams which you are really willing to connect to it. Yes, it's getting done. Exactly following the same way I'm supposed to connect all these transverse beams with the Longi beams. And at the top of the transverse beam we see some uncut portion which we can modify later. I will show you how you can cut the beam to your desired shape. There's an option available right there, and using that option you can cut your beam or columns to your desired shape in order to make the proper adjustment. So the name of that connection is clip angle. That connection family was being predefined, I mean predetermined by Revit. Actually you can make your own customized connection family. In near future you're gonna see it. In this project I will show you how you can make your own connection family. Okay, now let's connect the columns with the footings. Connection between the columns and the footings, they must be done. Here we go, the F2 footing, the corresponding column with that, as you can see in the screen. Let's take a dimension of the plate. This is the plate. Okay, so here's the dimension of the plate. There will be 4 bolts. The spacing between the bolts, it's essential. I have come to the 3D view. Let's turn off all the things except the footings and the columns, all other structural elements. I've turned off them all. There are the connections and the connection plates. right, the connection options, the base plate connection options, I have just select that two element and press enter. Select the column and the footing, and I just pressed the enter button. And medium, again, fine detail here. You can see it's nicely appearing in the 3D view. The plate and the bolts. Right, it's been done, so I'm doing the same for the rest of the footings and the columns. The base plate connection. Here we go. So I will keep doing the same thing. So keep watching. Okay, now let's place the slab at the first level parking. I'm turning on all the structural elements, turning on the visibility, making them appear in the 3D view. Alright, so my slab will be placed above all these beams of first level parking. Alright, just having a look over that 3D view. You can see the connections, they all are being done. They seems pretty perfect, right? Okay, I'm going to the first level parking. Alright, structure floor structure 100mm. I'm going to define, actually I'm going to use that 160mm concrete with 50mm metal that thing, and it has already a predefined thickness of 110mm. The concrete portion included with the metal deck. With the metal deck, you can see that zigzag portion is representing the metal deck. Right. I am going to use the peak line option, and I just simply pick the lines. I will just make the Okay, uh, let's make connections. The connections between the beams and the columns of first level parking. Right, I am in the first level parking plan. Now let's go to the section view, and here we go to view, the section view. Here I am. Let me go to the fine mode. So here it is, the fine mode. No, the fine view. And as you can see, that a gap between the beam and column, I kept that gap 20 millimeters, and now I'm willing to place a plate in that gap. Now let's try it. All right, at first let's put a plate in that gap. So the steel option is steel ribbon. Let's choose the plate option, and I need to select a work plane. This is the work plane. I have selected the plane. There we go. The rectangle option, stretch it till the end. All right. Alright, there's some visibility restriction. That's why it's not getting visible in the 3D view, as I hided all other structural elements. So yeah, it's getting visible in the section 2. Now it's time to place some boards. Let's go to the visibility graphics. If I reset them, yeah, now it's the plate. It getting visible. Now I'm willing to place some bolts. Here we go, the bolt option. It's the bolt option, the plate, and the beam of the top. I made the selection. Now let's put it. I need to select the plane of the bolt. The plane, this is the plane, and in that plane the bolt will be placed. So rectangle option, stretch it till the end. Right, 4 bolts in 4 corner. Don't modify the number of bolts. I want 3 bolts on each side, and the intermediate distance between them, let's keep it 100 millimeter. Side length, if I keep it 350, wouldn't be bad. I guess the length on side 2, 300. Yeah, that seems cool. The intermediate distance, I keep it 100 millimeter. If I keep it 200, it will get more close. All right, that's it. I have made the command. Now customize connection, create customized connection, and All right, now I am going to make schedules or quantify the materials, amount of materials, I mean how many beams, quantity of materials, how many columns, how many girders, the railing quantity, their weight. All these things are going to be determined in this video. So keep watching. Here you can see the schedule and quantities option. Let me right click over it. New schedule and quantities. All right. Here you can see we have several options. Let's choose the architectural and the structural, multiple category schedule, phase new construction. Okay, so at first I'm willing to determine the columns, the UC columns. So here's the structural columns option. And these are the available fields. All right, family and type, count. I want to keep it up. Length of the column, assembly name. I also added that field. Let's see what else can we add. Here are a bunch of options, bunch of fields. Right, this is the project parameters which I made at the very beginning of the project. Let's keep it here. Cut length. Cut length. This is, I think this one is also important because the columns which truly belong to the ramp, you can see I cut these columns according to my convenience. So I also want to specify their cut length. Right, that's it. Let's create the schedule. You see the family type and the cut length. These are the cut length. Right, these are all steel columns. So these are the family types, and now I want to actually that assembly name. There are certainly no assembly name specified here, so I want to delete this column. All right, I have deleted it. Now I want to find out the weight, the total weight of these columns. In order to do that, let me go to the sort and grouping. Right, can I sort them? Let's see. The cut length, ascending to descending. Right. Format, count, total. total weights. Sorry, I'm begging your pardon. No, I don't want to apply any filterization here. Let's try it now. The grand total is not appearing, so you make sure that you tick that grand total option in sorting and grouping field. And now let's try it. Yeah, you can see there are total 30 columns, and the weight of all these columns is about 10,323.96 kilogram. That's it. I mean, following that same step, I'm going to make schedule of all the beams as well. All right, let's do it for the beams now. Beams means structural, not beam system, structural framing, I guess. So, yeah, structural framing, this option. Now at first count. Cut length is not that necessary here. Object, elements and object. As you all know, when I placed all these beams, the Longi beams and the transverse beam, I filterized them, the beams of the underneath the ramps. They were being categorized as the transverse beam and the Longi beams. So I'm taking it into consideration, the elements and the object. This project parameter will help. Alright, the weight, the most essential field, and family and type. Okay, this one is supposed to, yeah, right here. The count, family and type. Okay, description, cut length, cost. I'm certainly not aware of the cost right now, so I'm not adding this field. There are 73 fields. You can add them according to your need. The paint area. This seems interesting, so I'm adding this too. It will represent the cross-sectional area of that particular beam. Alright, that's it. Let's make the schedule now. Click the OK button. Here's the schedule. So you can see, as I told you, that project parameters I created at the very beginning of the project, that elements and object, it's helping me to sorting the beams. You see the first floor transverse beam, first floor Longi beams, ramps Longi beams, ramps transverse beams. Alright, that thing. The planed area and unit. I want to keep it in square millimeter. That would be cool. Let's see. At that column, it seems unnecessary. Planed area, I want to delete it. Because when you see that family and type, then you will have a clear perception about the area of the beam and the type of the beam, also the the last value 40. Here you can see it represent the weight. It will give you a pretty clear idea about. All right, no filter. I'm willing to apply. So OK button. But the grand total will not getting visible. So here's the grand total, and as you are witnessing that we have several type of beams right here, beams of several cross-sectional areas. So I think it would be wise if I categorize them. If I mean right. Yeah, so now you can see we have figured out the weight of each and every individual beams, their quantity numbers and their total weight depending upon their family and type, and also the floors, first floor transverse beams, ramps transverse beams, ramps Longi beams, and ramps first floor beams. So the total weight of ramps Longi beams is 2687.70 kilogram. The total weight of ramps transverse beam is 2567.09 kilogram. So this is how you can make schedule of your model. This is the main advantage of Revit. When you use that software, when you model something using that software, you don't need to quantify the material individually into Excel sheet, or you don't need to use any other software like Bluebeams or things like that. You can certainly find out the materials quantity and make schedules using the model directly. So Revit offers pretty cool and nice features. Alright, exactly using the same technique, I will be finding out the quantification of the CC 100 millimeter CC layer, the foundations, the connections, the quantity of the plates, bolts. Also, I will make the schedule of the railings, the stairs, slabs, everything could be done here. So yeah, at least after watching it, I'm not gonna make that video that much long. That much portion I just covered, that little portion I just covered right now. After watching it, you will have that perception that how you can make the schedule or quantity takeoff from your Revit model. Alright, that's it. Thank you for watching. God bless you all.